All right, I'm going to talk about Burrows-Wheeler transformations, or BWTs. The purpose of BWTs is for string compression. They can also be used for suffix array compression, and they're useful for substring searching. If you're trying to, for example, search for a certain substring in a length of DNA. So I'm going to go through an actual example where we, first of all, find the BWT for a specific string, and then use that BWT to find that original string again. So let's say we have the string banana. This $sign is usually appended at the end of a string, and that's how you know where the start and end of the string is. So the first thing that you want to do when calculating a Burrows-Wheeler transformation is to list all of the suffixes. So a suffix is basically just the part of a string that includes from some index all the way to the end of that index. So for example, this suffix contains the entire string, but then if they're listed in order from in the index that you're starting at, then we start here and continue to go until we get to be at the other side, and then we start here and continue to go, and then we get the next one. So hopefully you can see how the $sign is iterating around until it's inverted and you have banana on the other side. The next step that you want to do is sort all of these suffixes. So by sorting, I mean sort in alphabetical order, starting with like $sign comes first and then A to Z order. So if you look, these are all sorted in A to Z order. Then the Burrows-Wheeler transformation, the BWT for the string, is going to be the last column in the sorted suffixes. So we have here A, N, N, B, $sign, A, A. Okay, so why is this useful, and how can we use that to find the original string? Well, I'm going to write it out real quick. This is our BWT that we found. Okay, so how could you use this to decipher from what we've done here to find what the original string was? I'm going to put these in column format because it's a lot easier. I'm going to delete this. So we know that this is the BWT, and this column shows all of the characters that we have in our string just sorted in the order that they occur. Well, this is useful because every time we have a BWT, we can actually find the prefix of that character from the BWT. So for example, if we look up here, we know that this is the BWT, but we can find the prefix because the prefix is just going to be whatever is on this side of our string in the sorted suffixes. So that might sound a little bit confusing, but I'm just going to go through this example and hopefully you'll understand what I'm saying. So what is the prefix of $sign? That's where we're going to start. So we know that we can, in the BWT, the $sign is right here, and we're trying to find the prefix, which would be A. So we can actually find that by looking right here and seeing the corresponding BWT. So it tells us A is the prefix. You know that because this corresponds when you have a $sign on this side, which is the sorted. See this? That's this column right here going down this way is the same as what we have sorted right here going down. And this column right here is the same as what we have going down this way for our BWT. So we can just know that A comes before $sign. And then we want to find out what comes before the last A. So we can look and see this is the last A. So the first to last A is this one, and N comes before it. So we can put N there. Then we want to come see what happens before the first to last N. So we look at the first N that shows up. That's going to be the first to last one. And then we can look and see that A comes before it. Now we're at the second to last A. So we look at the second A index and see that N also comes before that one. And now we can look at the second to last N. So we go down these, and here's the second to last N, and we know that A comes before it. So now we can put A there, and we're almost deciphered with this. And we want to look for the third to last A, and we can go down and see that B comes before that. And there we've deciphered our string, and we now have the original string. So why is this useful? Why would we ever want to do this? We would want to do this because we can, usually if you have a long string, BWTs tend to cause strings to, characters to repeat for long periods of time. For example, if you were to compress the BWT that we have, it wouldn't make a difference. It would look like this. You'd have this go to this. But let's say we had a huge amount of A's. I don't know how many A's this is, but let's say it's 15. Then we can compress it to just look like this, and you would save a lot of space. So hopefully that helps in your understanding of BWTs. Good luck working on these in the future.